This is an example of how to use the fundamental theorem of calculus. So the question is, evaluate the integral from -2 to 3 of x squared plus 4x plus 5 dx. So we use the fundamental theorem of calculus when we're evaluating an integral from point A to B. So this bottom value here is going to be our A value, and this top value is our B value. This will always be the case. Your bottom value will be your A, and your top value will be your B. The actual formula for the fundamental theorem of calculus is the integral from A to B of f of x dx is equal to the antiderivative evaluated at point B minus the antiderivative evaluated at point A. So we can start to take our antiderivative. So just two rules to remind you that you have to use in order to take this antiderivative is the integral of x to the n dx, which is equal to x to the n plus 1 divided by n plus 1. And this works for all integers except for -1. And then we also need to know how to take the integral of a constant. And the integral of a constant is just the constant multiplied by x. So for the first term, we have x squared. So it's going to be x cubed over 3. So it's going to be 1/3 multiplied by x cubed. And then we have 4x, and integrated is 4x squared over 2. So the 4 divided by 2 is just 2. So we'll have plus 2x squared. And then for the last term, we have a constant, so we just multiply it by x. So we have 5x. And you'll notice here that I'm using square brackets. I use square brackets because I still have to write in my bounds, and it's proper notation to write square brackets and write your bounds on either side at the end. Another notation you might see is someone write their antiderivative in round brackets and use a straight line at the end to represent their bounds. You'll also notice here that I don't add the integration constant. When evaluating an integral with bounds, you don't have to write the integration constant. So now we can start to plug in our values. So just to remind you, this is our B value, and this is our A value. So in the formula, it says to plug in our B value first. So if we plug in 3 everywhere we see x, we're going to get 1/3, 3 cubed, plus 2 times 3 squared, plus 5 times 3. And now we're going to subtract the antiderivative with our A value plugged in, and -2 is our A value. So if we plug in -2, we're going to get 1/3, -2 cubed, plus 2 times -2 squared, plus 5 times -2. So now if we simplify this, we're going to get 3 cubed, which is 3 times 3, which is 9, and then times 3 again is 27. And 27 divided by 3 is just 9. And then 3 squared is 9, and multiplied by 2 is 18. And 5 times 3 is 15, so plus 15. And then we're going to subtract this bracket simplified. So -2 cubed is -8, and over 3 is -8 over 3. -2 squared is 4, multiplied by 2 is plus 8. And 5 times -2 is -10. So now to simplify these brackets, 9 plus 18 plus 15 is 42. And -8 over 3 plus 8 minus 10 is actually -14 over 3. But since there's a negative out front, and this negative as well, it's going to turn into a plus 14 over 3. I got 14 over 3 because you have -8 over 3, and then to make 8 and 10 over the same denominator, we multiply 8 by 3, so we're going to get -8 over 3 plus 24 over 3. And then we multiply 10 by 3, so -30 over 3. And when you add those tops, you're going to get -14, and then it's all over 3. So now to add 42 to 14 over 3 into a fraction, we multiply 42 by 3, which is 126 over 3, plus 14 over 3. And 126 plus 14 is 140 over 3. Now, I usually just leave it as a fraction, but if your professor asks you to put your answers into decimals, this answer is approximately 46.7, and that's rounded to 1 decimal point. So now you can have your therefore statement. So you have therefore the integral from -2 to 3 of x squared plus 4x plus 5 dx is equal to 140 over 3, or approximately 46.7. And that is how you use the fundamental theorem of calculus.